Good afternoon, distinguished guests, ladies and gentlemen. Welcome back to the AI Real World Deployment panel at the Science for Life Symposium. And this is the event in the framework of VinFuture SciTech Week, VinFuture Prize Awards Ceremony 2024. One more time, thank you so much for coming here with us. Thank you. Ladies and gentlemen, the VinFuture Prize is a prestigious global science and technology award proudly originating from Vietnam. The topics we'll explore in today's panel are essential for advancing global scientific progress and have profound implications for human life. Vietnam is deeply committed to supporting scientific development and is playing an increasingly influential role on the world stage. In a rapidly digitizing global economy, AI has emerged as a key driver of innovation, offering competitive advantages to businesses and organizations that swiftly embrace latest technological trends. By advancing its AI industry and applications, Vietnam has potential to make a significant impact on the global stage, to disseminate scientific and technological knowledge to the public and connect generations of young scientists, inventors, and entrepreneurs with globally established inventors. For potential partnerships, the event today is held with the participation of distinguished speakers who have excellent expertise and experience in the field of artificial intelligence. In addition to our speakers today, we also welcome to the symposium many representatives, the one who working in the field of science, technology, and government. We are honored to have Professor Sir Richard Henry Friend from University of Cambridge, United Kingdom, and also the chair of VinFuture Prize Council. Welcome, sir. We also honored to have Dr. Lê Thái Hà, Managing Director of VinFuture Foundation. And we are honored to have Dr. Xuedong Huang, Chief Technology Officer at Zoom Video Communication USA, also the member of VinFuture Prize Council and also the chair of this session today. And now let's take a moment to introduce today's symposium's topics, and we will get acquainted with our chair and we will know who will be the distinguished speakers through a brief video. Video, please.
In recent years, AI has emerged as a key driver of global innovation, with applications extending beyond traditional boundaries. Its research and practical implementation are essential as this rapidly evolving technology increasingly influences all aspects of life. In healthcare, AI can bring breakthrough changes in improving the quality of medical care. In education, AI helps expand the possibilities of distance learning and supports the creation of data-driven courses. According to McKinsey & Company in 2023, AI could contribute an estimated $2.6 trillion to $4.4 trillion annually to business productivity. According to a forecast by Grand View Research, the global AI market will reach $279.22 billion by 2024 and $1,811.74 billion by 2030, with a compound annual growth rate of 36.6% from 2024 to 2030. To further discuss the opportunities, challenges, and new advancements of artificial intelligence, the VinFuture Foundation proudly introduces the symposium, AI, Real-World Deployment, as part of the 2024 VinFuture SciTech Week. The chair of the symposium is Dr. Xuedong Huang, Chief Technology Officer at Zoom Video Communications USA, member of the VinFuture Prize Council. The symposium also features speakers who are experts in the field of AI from academia and industry, including Dr. Hung Hai Bui, CEO of VinAI Vietnam. Professor Ngoc Minh Do from University of Illinois at Urbana-Champaign, USA, and Vinh University, Vietnam, member of the VinFuture Prize Pre-Screening Committee. Professor Ayan LaCoon from New York University, Chief AI Scientist at Meta USA, and laureate of 2018 AM Turing Award. and Professor Leslie Gabriel Valiant from Harvard University, USA, laureate of 2010 AM Turing Award, member of the VinFuture Prize Council. Following the theme of resilient rebound for the VinFuture 2024 awards ceremony, join us as we explore a new era where artificial intelligence will guide humanity to reach new heights across all areas of life.
Thank you very much for your attention in our introduction video. Ladies and gentlemen, and now I would love to invite to the stage Dr. Xuedong Huang, Chief Technology Officer at Zoom Video Communications, Chair of today's symposium, to deliver the introductory speech for our topic, AI Real-World Deployment. Doctor, please, the stage is yours.
Hello. It's really my great pleasure to introduce our distinguished panelists. And before I start that, I really want to actually share with you what AI can do to help this. So I asked AI what this is about. So I didn't do anything. What I displayed was completely AI-generated result. So as I said, large language models really did showcase amazing capability. I asked Zoom AI Companion how to compare, that is, summarize output. May not be 100% accurate, but it got most of the points. And then I asked, okay, with the amazing large language model, what is that you can do for me about productivity? And they talk about Microsoft Copilot, pros and cons, Google Gemini, pros and cons. There's a young rising star called Zoom AI Companion, pros and cons. Of course, there's a ChatGPT most of you are very familiar with. Once again, 80% accurate. No hallucination here. Before I actually end my introduction, I had breakfast with one of our council member, Pascal. She said, I never heard about the AI Companion. What the heck is this? I said, well, do you actually use Zoom meeting? Yes, I use Zoom meeting, but I don't know where the button is. I just actually started the meeting with her in the breakfast table, put the iPhone on the table, and showed her where the button is. Then immediately I got this email summarize what happened in the breakfast. Notice the time, 9:41. We were all lazy with jet lag. We had breakfast late, but with iPhone on the table, I summarized everything. That is what is happening today. So in this session, you will experience some of the amazing capability, and I want to close the introduction with this video because most of you have not heard about the AI Companion.
Work happy with Zoom AI Companion. Introducing AI Companion 2.0, the next generation AI assistant. Designed to help you get work done by turning information into actions. Zoom AI Companion can help our user to start her day by sorting through the noise and prioritizing what's important. Starting with Team Chat, our user can easily get caught up for her day by summarizing recent messages in this chat channel. Instead of reading through all the chat messages that have come in overnight, she can easily identify key message themes, allowing our user to have the information she needs to help prioritize and determine which chats need immediate response. And with the source links, our user can quickly link to the specific message in Team Chat used for the summary, making responses much easier and faster. Zoom AI Companion can help keep conversations focused and impactful. Inside of a Zoom meeting, our user can enable Zoom AI Companion and ask a question about the discussion to determine what the team has agreed on. Quickly and easily, the AI Companion can help answer the question without disrupting the flow of the meeting. During the meeting, our host can search for some ideas of icebreakers to help deal with tension. AI Companion can search the web directly from inside the meeting, giving the user access to the sources used, all while staying focused on attendees in the meeting. Much of the work begins after the meeting is over. Zoom AI Companion can help jumpstart your drafts. AI Companion can even adjust the output for a specific audience. In this case, we'll ask for the output to be a product spec that can be shared with a designer. In addition, our user can upload a file as context for AI Companion and ask for help with new ideas for some taglines on an upcoming ad campaign. AI Companion can help turn your information into action in order to get more work done. Our user can access the meeting's detail page to review the list of those invited, the provided attachments, and access the meeting summary and recording if enabled. She can continue to leverage AI to create action with the information in the meeting summary by instructing AI Companion to write an email to the CEO as a follow-up. Because the output is temporarily stored as context, our user can continue to iterate on the output by providing the additional context in order to make improvements before sending the email message. Work happy with Zoom AI Companion.
So that is the context before we invite our distinguished panelists on stage.
Thank you very much, Dr. Xuedong Huang, for your presentation to kick off our event today. Thank you very much. Distinguished guests, ladies and gentlemen, and now I would like to introduce to the stage Professor Yan Lei Kun, Vice President of Chief AI Scientist at Meta, and Silver Professor at NYU affiliated with the Current Institute, the Center for Data Science, and the Center for Neuroscience and Electrical and Computer Engineering Department. He also the founding director of Facebook AI Research and of the NYU Center for Data Science, and he will deliver the first presentation today on shaping the future of AI, strategies for reaching human-level intelligence. So, Professor, please, it's your time.
Thank you. So, XD told you about all the wonderful things that AI can do today. And what I'm going to try to tell you is that you haven't seen anything yet. This is going to get very different and a lot better in the next few years. So today, we have AI technology that can do amazing things, but it's still very limited. We're still very far from being able to match or reproduce human intelligence. We're not even able to reproduce animal intelligence. We do not have robots that are anywhere close to being as smart as, let's say, a cat. So that may sound a little strange, but it's really true. And we need machines that have human-level intelligence because there's going to be a future, maybe a decade from now or something like this, where every one of us will be walking around with an AI assistant. They will be living in our smart devices. They could be smartphones. They could be smart glasses of the type that Meta is building, for example, or other things of this type. And this will be like having assistants working with us at all times. It will amplify human intelligence. We shouldn't feel threatened by those things. We should feel empowered by them because they will make us smarter. It's like every one of us will be the boss of a staff of super intelligent people, okay? That's a good thing, I think. But we need those machines to really have human-level intelligence because that's the best way we can interact with them. And also that's the best way for them to understand our world. So that's a big goal that we need to achieve. And people would not admit to that goal a few years ago because it was too distant. But now we're kind of starting to see it a little bit. So we need systems that are different from the current AI systems that we have today. We need systems that can understand the physical world. We need systems that have persistent memory. We need systems that can plan complex action sequences and they can reason, and systems that are controllable and safe. Current AI systems, large language models, chatbots, are incapable of doing any of this. I mean, they do it, but not well. And so we really need some new paradigm, new technology This is what an LLM is. An LLM is trained to predict the next word or the next token in a sequence of symbols, sequence of words, for example. And because it's trained to predict the next word in a sequence of words, we can use it to generate text, what's called autoregressively, by producing a word and then injecting that word into the input and then producing the next word, etc. Those systems do not have the mechanism for reasoning, okay? They produce text, and they're pretty good at doing that, but they don't really reason. They don't have the mechanism for this. To have a mechanism for reasoning, you need somewhere for a system to really think about a question for longer, a complex question for longer than if it's a simple question. And LLMs really are not capable of doing this. They just don't have the right architecture. So I'm not going to get technical on you, but what we need is new architectures that are capable of reasoning. And one possible way to achieve this is through a concept that's called world models. So what is a world model? A world model is a mental model of the world that all of us have in our head. Most animals have a world model as well. And what our internal world model allows us to do is imagine what a sequence of actions is going to do, what effect is going to have on the world. If we can imagine the effect of a sequence of actions, what that means is that we can plan a sequence of actions to arrive at a particular goal. Okay? And really, that's the essence of reasoning and planning. So the big question, and there is sort of various complex ways to build those things, which I'm not going to go into, using hierarchical planning, etc. Those are ideas that are not completely implemented yet, but that we're working on. At least some of us who are working towards the next generation AI system. And the big question is, how do we build those systems? How do we get machines to learn how the world works? How is it that humans and animals learn how the world works? Perhaps we can get some inspiration from this. And so I made this proposal a few years ago, something called objective-driven AI, and I've written a paper on where I think AI research should go over the next 10 years or so. And I'm sort of going to give you a little bit of an idea of where I think this is going. So we're missing something that's really big, because if we had AI systems that were capable of human-level intelligence, we would have self-driving cars, we would have domestic robots, we would have robots that can do anything that humans do, and we don't. So we're missing something really big. How is it that a 10-year-old can clear up the dinner table and fill up the dishwasher the first time you ask them to do it? How is it that a 17-year-old can learn to drive a car in about 20 hours of practice, and we still don't have self-driving cars? Okay, so we're missing something really big. And perhaps this is explained by the following remark. Take a big LLM of today, a big chatbot. It's typically trained with 20 trillion token, 2 10 to the 13 token. The token is kind of like a word. The token typically has 3 bytes, so that's 6 10 to the 13 bytes. Let's round that up to 10 to the 14 bytes. Now, take a human child. A 4-year-old has been awake a total of 16,000 hours. Over the course of 16,000 hours, there's about 2 megabytes per second going to the visual cortex through the optic nerve. So do the arithmetics. And the data volume that a 4-year-old has seen through vision is about 10 to the 14 bytes. Same amount of data. Now, the text for the 20 trillion token would take us several 100,000 years to read, any of us. Okay? A child can see as much information in 4 years. What that means is that we learn a lot more by watching the real world than by reading text, at least in the first few years of life. And we need our machines to do the same. We need them to learn from video. So, and you know, babies and animals learn an amazing amount of background knowledge about the world in the first few months of life. You know, figuring out intuitive physics, for example, the fact that objects that are not supported fall, the fact that an object that is hidden behind another one still exists. All of those things, we're not born with them. We kind of learn them in the first few months of life. So how do we do the same with machines? So of course we could try to use the same idea that we use for large language models and chatbots, using a technique called self-supervised learning to train those systems. How is a chatbot trained? You take a piece of text, you corrupt it in some way by removing some other words, and you train a very big neural net to predict the words that are missing in the text, okay? And it can regenerate the text, which is why we call it generative AI. Now, people have had the idea for at least 15 years to do the same for video. Take a video, corrupt it in some way, maybe mask the second half of it, and train some gigantic neural net to predict what's going to happen in the video. If the system is capable of predicting what's going to happen in the video, perhaps it has understood how the physical world works. That has been a complete failure. We've tried doing this for 15 years, it doesn't work. And the reason it doesn't work is that you cannot really predict everything that can happen in a video. It's easy enough to predict what word can follow another word. You cannot predict exactly, but you can predict a probability distribution over words. But you cannot produce a probability distribution over all possible video frames. That's basically intractable mathematically. So the alternative to this is something I've called JEPA. What that means is Joint Embedding Predictive Architecture. The idea of joint embedding, which I'm not going to go into the details of, is very old. But the basic idea is that instead of predicting everything that is going to happen in the video, you don't predict everything, you predict some abstract representation of what's going to happen in the video. So if I take a video of this room and I slowly move the camera and I stop it at this point and I ask the system to predict what the rest of the video looks like, it's going to predict there's going to be more people sitting in chairs and the room probably is going to end at some point. But it's not going to be able to predict exactly what every one of you looks like. That's impossible. The information is just not there. And so you don't want to predict all the details when you make prediction. You want to predict an abstract representation of what goes on. This is what the JEPA architecture is doing. So the cool thing about this architecture is that it can also be used to train world models. So on the left, you have the generative architectures. On the right, you have those JEPA architectures. They are different. I'm saying the future of AI is going to be in those joint embedding architectures. They are not generative. Everybody is talking about generative AI. The future of AI, in my opinion, is not generative. Okay, let me skip ahead a little bit. You can apply this to video. It works really well. And I'm just going to show you a short demo of a system that is a JEPA architecture. It's been trained to basically observe what happens when you move a robot arm on a table and you slide the robot arm so that things happen on the table. There's a bunch of chips. You see those blue chips, they move around when the arm moves. And the task that we're training the system to predict essentially what's going to happen to those chips as you move the arm around. And then we're using this learned world model for the system to plan a sequence of action so that it arrives at a particular goal. For example, producing, putting all the blue chips in a little square as is shown here. So you let the system think about what's going to happen, kind of imagine what the result of its action is going to be, and then it just executes the action. And I'm going to show one video of this going on. So this is for another example, not the chips, but these are various examples of the system having planned a sequence of action to arrive at a goal. And here is what happens for the chips. So at the start is the initial position of the chip. On the right is the desired position. And what you see at the bottom is the actual position that it arrives at after just 5 actions. Actually, 25 actions in this case. So this is kind of a first demonstration that we can train systems to understand how the world works from video, and then use them to plan sequences of actions. The general concept of this is very old, but the application of this in the context of learning is relatively new. So I'm basically making recommendations to people in AI research and development. Abandon generative models in favor of those JEPA. Abandon probabilistic modeling for reasons I'm not going to explain. Abandon contrasting method, also for reasons I'm not going to explain. Abandon reinforcement learning, I've been saying this for 12 years. And those are the most popular approaches to machine learning today, so I'm not being very popular at the moment. But that's what you want if you want to arrive at human-level AI. And we need this because we want AI systems to basically eventually constitute the repository of all human knowledge, accumulate all human knowledge so we can ask them any questions, have them help us in our daily lives. We need those AI platforms to be open source because we need our AI assistant to speak all the languages in the world. Okay, you can download Llama, the Meta open source model right now. It doesn't speak Vietnamese very well. It's been trained on a bit of Vietnamese data, but it doesn't speak Vietnamese very well. We need our future system to speak all the languages in the world. Now in Vietnam, you're lucky enough that there is basically one dominant language. A few weeks ago, I was in India. There's 700 languages in India. It's a much tougher issue there. And the only way we can get there is if those AI systems are trained by lots of entities all over the world in a collaborative fashion. We're not going to get this with a SQL proprietary platform. It has to be open source. It has to be open source, and it's important that governments understand that they need to not regulate open source AI out of existence, because that's the only way we're going to get human-level AI, and those systems are going to amplify human intelligence. Thank you very much.
Thank you very much, Professor Jan Le Cun, for your lecture on shaping the future of AI. Thank you very much. And now, could you please come back to the seat so we can follow easier to two more presentations of our distinguished speakers. And now, it's time for us to welcome to the stage Professor Ngọc Minh Đỗ, the Thomas and Margaret Huang Endowed Professor with the Department of Electrical and Computer Engineering, University of Illinois at Urbana-Champaign, and Honorary Vice Provost at Vin University, with a presentation of AI for healthcare applications. So, Professor, please.
Thank you. Thank you very much. It's wonderful to follow the footsteps of Dr. Xuedong Huang and Professor Jan Le Cun. You already see the introduction and overview of AI. In the next 9 minutes, I would like to share with you the applications in the context of healthcare. I think that is something that all of us would be interested in having. Everyone in the world would like to have a better quality of life. So first, I'd like to share with you about the Joy Research Center, VinUni, Illinois Smart Health Center. This came out from a generous support from Vin Group, $13.5 million over a course of 10 years. And we aim to produce 50 masters, 50 PhD, and 10 postdoc, working on a range of topics, essentially AI data science, and combine that with sensing technology that provide accessible healthcare to everyone. And we really think that here's some example of the applications, and there is a website that if you are interested, you could take a look. But at the high level, let me share with you that we recognize that to provide accessible healthcare, we need to have a technology that is scalable, technology that can easily adapt to different local contexts. So problems like how to monitor an outbreak of like COVID, or how to develop new sensing technology, at a platform like several $1,000s that can be put in any local clinic at a cost of $1, can do an early cancer screening using a liquid biopsies, like some a drop of blood or saliva. Also, technology can enable people to have a quick rehab. So all of these, at some angle, there is an element of AI power component. So for example, we have a project with jointly with UIUC that we can develop a platform, basically a PCR machine, but it can run on a smartphone device using advanced image processing, advanced biosensing technologies, and can deliver the results that typically can only be done now in a lab. The second example I'd like to share with you is a project that I am fortunate to be part of at UIUC with alliance with the Mayo Clinic, which is #1 hospital in the US. We got $33 million from ARPA-H to tackle the following problems. So for many of the cancer treatment nowadays, the best way is to take a surgical and remove those cancerous tissues. But the big challenge is you want to make sure you don't leave any cancerous cells left in the body. But you want to minimize the amount of removal tissues, right? The traditional ways is people take out the surgical operations like breast cancer surgeries. They take out some tissues. That tissue need to be sent to a pathology lab, which look at in the microscopy and check whether there's any tissue cancer left. And that process takes a long time. All along the way, the patient is on the operating table. You know, the surgeon we work with, he told us that every minute in the surgical room is like eternity, right? So many times they have to close up the operations, send the patient home, and then the sample now in the pathology lab, they can have a time to look at it, and they found there's a cancer, right? Mayo Clinic is a #1 hospital. Their recall rate is at 20%. Many other hospitals about 30, 40, and 50%. So many times we bring patients back and have another surgical operations. Very painful, very costly. So the technologies that the teams at UIUC together with Mayo Clinic is we develop real-time optical microscopy that can basically provide 5,000 pathology per second, right? Of course, no doctors can watch and see all of those images, so AI was a crucial tool that we can scan through those images and make a quick decisions whether the surgical need to be continued or the doctor need to examine more carefully. Another project that related to healthcare is also funded by ARPA-H. So this is a $21 million funded projects. Combine advanced manufacturing with cancer research, right? So the way that a lot of research in cancer nowadays and potentially precision cancer treatment is you can pull out a tissue sample of a cancer patient. You can grow that in a small lab environment. You know, typically in the past people do it in 2D, like a Petri dish. Nowadays we can grow them into a 3-dimensional tumor model, like an organoid or spheroid. And you can grow thousands of these, and you can study the effectiveness of certain drug treatments, right? And then based on that, maybe you can find out what is the optimal treatment, optimal drug combinations. To do so, you really need to have a very systematic way of extracting out tumors, samples, cells. You put into systems that like an industrial 4.0, you know, in manufacturing, like most of the car nowadays going through those kind of robotic systems, but not yet in biology. And we can monitor that process with a lot of data and AI, similar to what you just saw with the example of DIMO-1 model. Based on that, we can predict what is the intervention, the treatment that we can grow those tumors, or what would be their reaction to various type of treatment. Another example we like to share is systems that allowed, basically, you know, we are walking around and our quality of life is heavily depending on how we can move around effortlessly, right? And that is a systems that have a neurological signal, have a muscle, have a skeleton. How they work together is really a wonderful question, and they can be modeled by control systems with various feedback. We can now intercept and measure a lot of different signal along those process. We can build a digital model, a digital twin. So for example, we can make a prediction. If I have this particular, let's say, recovering from a stroke, what kind of best optimal rehab exercise I can do, right, repeatedly. Before even doing those exercise, I can run 10 different protocols or use computers, AI, to find out what is the optimal treatment and then apply it to a real patient. So all of these applications require AI to some degree, but let me just give you a teaser and we could have a more discussion later. All of these is not foolproof. Here's one paper that was published almost 10 years ago by a good friend of mine, showing that, for example, all of these AI systems can be very easily fooled, right, by generate some random patterns, but can be recognized with a very high confidence as certain type of objects, right? So-called hallucination effect here. Another thing we need to watch out for is if you look at a holistic systems, many times AI or machine learning is a tiny component. Again, this is a nice paper by Google Group almost 10 years ago. So we need to very humble and put in perspective, even though AI got a lot of headline, but it is only a small component if you really want to build something that have a significant impact. Finally, there is a recognition out there in the clinical world that many times the systems built by AI was developed based on some existing or curated data, but the minute the system's ready to deploy it, of course environment change, different hospitals would have and as things grow, there is a so-called domain shift, and many of the systems no longer be effective, right? So ARPA-H recently made a big call for developing systems that can really take advantage and be able to adapt, can become more intelligent as it can deploy and operate in the real world. So there is a topics, again, this is the last slide. I like to maybe just leave it. If any researcher or students here, I think the problems of how to provide systems that adapt even after being deployed in the real world is a very interesting research problems. I just make a quick plunge about a paper that we're going to publish, presented at NeurIPS. Basically, the systems, test time adaptations, we need to analyze them very carefully because there are issues that if you, leave too much of adaptation, the system can also easily fool or get off track. So all of that, I think my high-level comment here is AI need to be put in the context of a small component, again, a bigger systems. There are a lot of things that AI can fail, but the excitement of how to bring AI and power many applications is a very exciting time ahead. All right, thank you very much.
Thank you very much, Professor Ngọc Minh Đỗ, for your speech on implementing AI in the healthcare applications. Distinguished guests, ladies and gentlemen, and in the symposium today, we are honored to welcome an impactful leader, Dr. Hải Hưng Bùi, CEO at VinAI Vingroup, Vietnam top 20 artificial intelligence research companies in the world. And please welcome to the stage with the presentation of democratizing future innovations, making AI accessible to everyone. Professor, please.
Well, thank you, everybody. My name is Hung, and I'm the founder and CEO of VinAI. It's a great pleasure to have this opportunity in front of a really fantastic audience today. So I just want to spend the next few minutes to share with you some of the insights that I've gained in trying to do sort of like world-class AI research in Vietnam and some of the things that we've learned from that, right? So let me start with sort of like a boring slides. We look at all the recent breakthroughs in AI today is all about putting more data, more GPUs, and a lot more money into training this giant AI models, large language models, and so on. And it comes to a point where it could actually cost, $200 million to train like a single model today. It's natural that, being here in Vietnam, we have to ask the question whether this is actually sustainable, right? What if the resources are insufficient? And today we know that the hardware are pretty expensive, and usually it consumes too much energy, costs too much, and you'll have potential issue for sustainability because these things just consume too much energy, right? So when I try to think about what sort of really important problems that needs to be addressed, right, and do it in a place like Vietnam, I'm forced to deal with the reality that places like Vietnam, resources are limited and constrained, right? Which kind of like give an excuse to go back to 5 years ago in 2019 when I decided to leave my job at Google DeepMind, moving back to Vietnam and founded VinAI, right? So, and very quickly, I realized that, in places like Vietnam, affordability, accessibility are really important, right? It actually are necessities. And to be able to do something really useful and interesting in Vietnam, you have to be able to find a way, right, to turn resource constraints into catalysts for innovation, right? And this is something that it's really important for us from day one. My insight is that, yes, the lack of resource can actually lead to innovation as long as you have talents, right? And talking about talents in Vietnam, this is what we managed to build in just 5 years, right? At VinAI, in just 5 years, we published more than 170 papers, all in top-tier conferences in AI. So we're talking about the likes of, NeurIFS, ICML, iClear, and so on. And we've recognized as one of the top 20 worldwide industrial AI research labs based on our publication track record. Right? We've also started a pioneering AI residency program in Southeast Asia based right here in Vietnam. And so far, we managed to train more than 100 AI residents, right? And many of our AI residents, after they graduated from our program, are now in the top PhD programs in AI in the US, and some of them are actually interning in places like Microsoft AI, Google DeepMind, and so on today. Speaking about our mission, right? As I've said, accessibility, affordability is really important, and that's a way to bring AI to the hands of everyone, right? So our mission from day one is how to actually, make AI accessible to everyone. And as an engineering team, we want to do that through world-class AI research and engineering. Okay, so there are two key challenges that we have to face, right? The first has to be efficiency. So I think I've talked about this already, right? How do you be able to cut down the cost of serving the AI models and also cutting down latency and things like that? How do you make these AI models more efficient? And the second issue that we have to deal with is kind of like an opportunities problem, but at the moment today, there's still a lot of concerns about privacy when one users tend to use these AI models, because if you have to go to the cloud, you're not entirely sure whether you want to share your private knowledge with a system like ChatGPT. Okay, and all of these are really important problems in the market, right? And I'll just give you some examples of along the line of how we can actually be able to make this AI model more efficient, right? So talk about image generation, right? So you all know the image generation today, is being done by this, stable diffusion models. Diffusion models is something that takes many, many steps, and through our proprietary method, right? Which is actually state-of-the-art, published in places like CVPR and so on, we managed to take this stable diffusion model, distill it to a one-step model, and therefore are able to generate images in real time, right? As you can see on these images here, as you type, right, you are able to generate these images in real time, and therefore cut down the cost of image generation. what about efficiency for large language models, right? So first of all, thanks for its open source efforts by, the AI lab in Meta. Now we have access to very capable models, for example, Llama models, right? So that's the really great starting point for us, because you can start with these really capable models, and you think about how you can actually further optimize these models, make them even smaller, and how you can actually feed that and optimize that to be run entirely on smaller devices. Right? We've shown evidence you can actually do that, right? String out these models further and getting a couple of getting further speed ups if you start doing that with the various methods that we've investigated. Accessibility in Vietnam obviously is important, right? So Jan just mentioned that we really need sort of like coordinate methods so that things like large language models can understand like the entire languages in the world. So at VinAI, we pre-train for GPT. And Pho is the name of the famous Vietnamese noodle. And we also make that open source, right? So today, Pho GPT is made open source in Vietnam. It's only a 4.5 billion parameter model, right? But it's quite capable, and the people love it because you can actually run this thing even on your desktop with just my GPU. Okay, so let me just spend a few minutes talking about privacy, right? And why I think is a really important problem, right? We want, right? Every one of us, right, want the next generation of things like the assistant, right? But the AI that actually provides us with really capable assistants needs to have access to our private information, right? Whether that's actually emails, chat messages, photos and videos and so on, right? Right? And we're just not comfortable sharing these models, right? Or this information with models like ChatGPT today. So what is it that you can actually do about it, right? Now, fortunately, right, everything that you do about efficiency, right, brings us to the point that today we can run quite capable LLM, also image generation models entirely on device, right? So all the compute can be done on device. The data never leaves your phone, right? And everybody can feel safe and secure about, never have to actually share your private information with another corporate. Okay, so this is what we adopted and tried to build an app, a personalized and private app to run entirely on device. It's called Mia, and for the next minute or so, let's watch a video of what Mia is capable of.
Information keep piling up on our phone, but when we need to find something, that's another story. I am Mia, the digital memory assistant that remembers everything for you. I can capture text data from any of your favorite communications app, like that long conversation you have on Slack. I can help you remember important links, then put everything into one searchable gallery. Need an overview of your saved content? I can summarize it for you. Need more info? Just ask. I'll give you the latest updates from your Slack channels. Clarify a team member's message with a detailed reference. Check your emails. Or recall the Christmas link you saved last week. The best part? I run on your device, so your memories stay private and accessible wherever you go, even without the internet. That's me. I turn scattered conversations, links and text into instant insights, just for you. Soon, I'll understand your photos, videos, and more. Your memories, always available.
All right, so that's just a glimpse of what is it that you can actually do entirely on device today. And I have to say that since I started using the smartphone, and I had to deal with information overload, I've been waiting for a system that can actually help me, right, to resolve these issues and help me to deal with all the information that I have to go through every day. Okay, so this is actually a photo of a very famous mountain in Vietnam called Phan Xipang. There's a hidden message behind this photo, right? And the message here is that think about hiking, right? As you sort of try to reach the top, you also have to deal with the lack of resources and also sometimes the lack of oxygen, right? And the people in Vietnam actually very used in doing so, right? In just 5 years, we managed to build a world-class AI team in Vietnam. Thanks to all the talented colleagues in Vietnam, we've managed to really push the state of the art in working on really meaningful missions. For example, like making AI accessible to everyone. And I hope that some of the people here today would resonate with the missions that we've chosen and could actually be our partners so that we can actually work on these really important problems in the future. So thank you very much.
Thank you very much, Dr. Hưng Hải Bùi, for your speech. Now, would you please remain on the stage and please be seated for the panel discussion right now. We are moving to the panel discussion. Yes, please be seated. And now we are moving to the panel discussion. And I would like to welcome back to the stage Professor Yan Lê Kun, Professor Ngọc Minh Đỗ, and Dr. Xuedong Huang, along with our distinguished speakers, Professor Leslie Gabriel Valiant from Harvard University, laureate of 2010 AM Turing Award, and also the member of the VinFuture Prize Council. Please welcome to the stage our panelists today, and Dr. Xuedong Huang will be the moderator of this panel. Thank you very much. Yes, and now is the time for Dr. Xuedong Huang to moderate the panel today. The stage is yours.
Can we start now? Okay, looks like we got a silent permission. I really enjoyed the 3 keynote speakers, but what's more exciting, we have this unique combination of distinguished panelists from both industry and academia. So we have also 2 Turing Award recipients in this panel. So the density of IQ on AI is very high. I want to first ask the question about AI. What the heck is AI? And I know Yang Lu Kung said, the current large language model is going to may not end to leading us to the AGI, right? But even with the current AI large language model, we are having a lot of challenges, including hallucination and safety. So I want to ask the panelists first about the realities and the hypes. So Professor Minh Du, maybe I can pick you first, because you're a professor, right? Unlike people like me working in the industry, we just got stretched and stressed on the reality.
Thank you, XD. No, I think, to be honest, at the university now, a lot of the time we are concerned that we don't know what is, the industry is moving. We don't have the resource. We don't have the real problems. And sometimes it is I often see, our university alumni, people who are running like Fortune 500 company and coming to UIUC and say, well, I just need an AI story for my company. My company is specialized in X, but it seems like every CTOs I met talk about AI, so I need to do something to it. And I feel is a very concerning, right? Because as you mentioned, That is, people catch on the hype, and if it's not delivered, then it is big consequence for everyone.
Yeah. So probably the most vocal, critical person is Yang Lokong about the hypes and the reality. Also, he is really the person who invented the convolutional neural nets that changed the computer vision for all of us. So I would love to actually hear the feedback and the comments from Yang.
Well, I think you see, okay, does that work? Yeah.
Yes.
I think you see excessive opinions about AI on both sides. There are, people who see AI systems like AlphaGo and say, oh my God, that's it, next year we're going to have, human-level AI. And of course, there's been a long repetition of such event over the course of the last 6 decades in AI, where computer systems were able to do something better than humans, and some people overreacted to it and saying, now the problem is solved. And that includes very prominent people in AI, Turing Award winners, who said, within 10 years, the most intelligent entity on Earth will be a computer. This was said in the 60s. So what's happening, I think, is that regularly, at regular intervals, there's a new paradigm in AI, and then a number of relatively young people say, that's it, we have the problem solved, and now they can't imagine all the obstacles that will be met on the way to making those things practical. And they hit those obstacles, and then that paradigm disappears and a new paradigm occurs, and now a new generation of young people makes the same mistakes again. Okay? Now, this is not to say that we're not making progress in AI. We are making progress. There is no question, absolutely no question, that at some point in the future, we will have systems that are smarter than humans in all domains where humans are smart. Okay? We should not call this AGI, because human intelligence is not general at all. Human intelligence is very specialized. In fact, every form of intelligence is specialized. Animal intelligence is specialized, human intelligence is specialized, and computer intelligence is even more specialized. So what does that mean for AI? AI is a collection of skills and also an ability to acquire new skills very quickly. The faster you can learn, the smarter you are probably, right? Or the smarter you can become, at least. But the fact that a particular entity is smarter than you in one particular area doesn't mean it's smarter than you in other areas. So it's not because we have LLMs that can pass the bar exam that we can, domestic robots that can clear up the dinner table. It's a collection of skills, and there is no such thing as a linear measure of intelligence. It's very highly multidimensional.
Yes, thank you. So we have another Turing laureate, Professor Valiant. Do you want to add?
Yes, I suppose for a general scientific audience, maybe the strange thing about AI is that clearly there's something incredibly powerful going on. That's very amazingly powerful science and technology. And yet there's this great disagreement even within the field, even the experts, even the people doing it, about what really is going on. And I think that's pretty unusual, I think, because in most scientific fields, there's a big area of established science where everyone agrees, and then there's a small area of current research which is under debate. So in AI, kind of the meaning of it all is all up in the air, I think. The experts put different opinions, and we can line up in different ways. So I think the fact that the 3 talks were all very positive, I thought is very good, because I share an upbeat view of AI. But so clearly, the fact that there's hype is probably not quite the right word, because people really disagree on the meaning of current AI. It's not that they're lying to you, necessarily. So I think parallel to all these developments, advances in particular systems, I think we'll also converge in understanding what AI means and what it is.
Thank you. Yeah. So whether it's a hype or not, AI is a tool that is going to help all of us to improve productivity so we can have more time. We have industrial expert and who also demonstrated some of the amazing capability in Vietnam. So can you tell us about it on the productivity and your view, how AI is really going to help all of us, the whole society?
Well, I've been working on AI since, I was a grad student, so that's many, many years ago. I just feel really excited about this particular time that we are right now, right? Because I think to me, the ability to understand language is actually close to human at heart, and if you can actually speak to a person using the native language of that person, I think it's really touched upon, right, the whole range of emotions and what is actually at the core of humanity. And I think the technology like large language model, I'm sure that it has a lot of limitations, probably hallucination, limitation in terms of reasoning, analytical capability, and so on, mostly generative today. It's really great at creativity, but maybe has limitation in terms of analytical reasoning. But right, I think it's just kind of like for the first time, right, it touches upon the lives and imagination of just about everybody on Earth, right? And I think that's really bring up this new level of excitement, among so many young people about what what AI can do, and what that means is that the field is going to make a lot of progress in the future. Breakthroughs are expected. And I think for the first time we can talk about the possibility. We probably also plan for the future of what if we reach human intelligence, right? And I think how that's going to impact society and so on. And I think all of this problem is not just countries like US and Europe need to deal with it, and China need to deal with it, but all the countries in the world, right, including smaller countries like Vietnam or developed countries, and it's going to impact all of us, no doubt about that.
Yeah, I agree. I do not want to get into the debate whether AI is going to be, smarter than us collectively, but the AI is going to help us regardless, right? Yang LeCun is also working in the industry Meta. He is the chief scientist at Meta. I would love to get your view about productivity, how Meta views AI, even though it's not AGI yet.
So, about 11 years ago, Mark Zuckerberg and the CTO of Facebook at the time, Mark Schaeffer, decided that AI was going to be a strategically important technology for Facebook, and hired me to create a research lab called FAIR. That meant Facebook AI Research. Now the company changed the name, so we had to change the name of the research lab. So now it's called Meta FAIR, and the F now stands for fundamental. And one other reason why we changed the name is because in the meantime, AI became central in the sense that for the better part of the last 11 years, Meta has used AI a little bit in the background for content moderation, for translation, for all kinds of things of this type, for helping users do various things. But it was a little bit in the background. What happened in early 2023 is that AI became really prominent, and Meta decided to have an entire product division devoted to AI. So there's 5 product divisions at Meta. There is Facebook, Messenger, which I understand is extremely popular in Vietnam, WhatsApp, Instagram, and Gen AI. The name might need to be changed, if I'm right, because AI may not be generative eventually. But that Gen AI organization produces a product called Meta AI, which is a chatbot assistant, which you can access through Messenger and whatever. And also produces the Llama set of models, which are open source foundation models. They can be used by just about anyone. I've been traveling a lot and talking to a lot of people in startup and large companies across the world. Almost all of them use Llama in one way or another. And it's really kind of enabling a new industry that was really not possible before. And so in terms of productivity, I think I'm going to use a word that's has been used by Mark Zuckerberg to describe one application of AI, which is coding, okay? Probably the biggest productivity augmentation that AI brings today is for software developers, for programmers. And to some extent, that's kind of one of the most complex things you could ask an AI system to do, but it turns out it's not that complex because it obeys a lot of templates and you just have to rely on the experience of a lot of people and just to help programmers. But the phrase that Mark Zuckerberg used is that programming or software development coding is the apex predator of intelligence, okay? I'm not sure what you should read into this, but it's like one of the most perhaps intellectually complex things you can do. And if you can write code, you can do math, you can do reasoning, you can do all kinds of things. So it's kind of a special case, if you want, of the general question of reasoning. So what's happened is that we've divided the AI effort at Meta into two separate divisions, and Google has done similar things. One is Gen AI, which is a product organization, and the other one is FAIR, which is a research organization. At FAIR, we work on the next generation AI systems. We don't work on LLMs. LLM now is in the hands of industry, product people. I tell students, if you're getting into a graduate program in AI, do not work on LLM. It's completely pointless. You're going to be in competition with people with billions of resources. I mean, there's no point. Even if you are a small company, don't train your LLM. Just download an open source one and fine-tune it for your application. But like, there's no point doing it yourself. It's a waste. And so the research division is working on the next generation system, and I kind of alluded to this a little bit in my talk.
Thank you, Yang. I want to second that Zoom AI companion federated the Llama. Thank you for open sourcing that. In addition to OpenAI GPT-4 and Anthropic, so Zoom really combined some of the best models, both open source and the closed source, with our proprietary way of orchestrating everything. That is far more cost effective. So I just want to take this opportunity to thank Meta for the leadership, to really pushing AI forward.
Most welcome.
So given that, I really want to just ask two professors in academia, and how do you view education that can take advantage of productivity and the AI, what AI can bring to help us modernize the way we teach and learn?
Yeah, great question. I think we talk about the hype, right? And to me, it's the best antidote for addressing the hype is education. Right? A lot of students, young people, also, general public are interested in AI. I think this is a wonderful opportunity to teach them about mathematics, about logic, about reasoning. Because of a lot of really good practice in AI research, like open source, making research reproducible, making data publicly available, it's really helping many other surrounding industry, right? You asked Dr. Hưng question before. Every time I go back to Vietnam, I see the indirect benefit of AI, which is really the precursor, so-called digital transformations, right? A lot of things get digitalized, and that, again, it creates a huge opportunity for educations and training, but it reduce a lot of bureaucracies in the systems. I think it have a very general benefit that sometimes we don't see immediately yet.
So I'm afraid our time is up. Now I have to open the floor for questions.
Yes, thank you very much, our panelists, for your wonderful discussion. And now it's time for the Q&A session for all the audience can connect with our top scientists in the world. And now I want to see your hand waving to raise the questions for our panelists today in the field of AI. So yes, a lot of hands waving. Yes, the man over there. Thank you very much. It's your time.
Okay, hello. I have a question to Yang Le Cun. So thank you for our quick talk in French before the discussion. So I don't have the question on the AI, but I have a question on the research environment. So, okay, you born in France, I study in France. You mentioned now you in the US because you have a very good research environment, Ben Lab. Everyone know Ben Lab. Myself, I used to be data scientist in France. I come back to Vietnam. My high school friends play Việt Quốc now for Google Translate. So what kind of condition that can attract you coming back to France is change comparing to US now? Or what condition, what environment in Vietnam do Vietnam have opportunity to attract famous, well-known AI scientists to come back to Vietnam? So please.
Excellent question. I'll tell you a little bit of my personal history, okay? So I did all my studies in France, including my PhD, and then I went to Canada for a postdoc, and then I was recruited by Bell Labs, which was in the late 80s, and Bell Labs was kind of a mythical place, right? You could not refuse an offer from Bell Labs. I went there with the idea of studying 2 years and then going back to France. But there were really no similar opportunities in France. There were industry research labs at the time in France, but they didn't have the same kind of level of ambition, if you want, that you could see in a lab like the labs, or at the time IBM Research or Xerox PARC. There were a few other labs at the time that existed in the US. There were a few in Europe, like Philips Lab and a couple others. But there were really no opportunities for kind of young scientists who had big ideas, other than going to academia. But academia is a different world, right? I mean, I have nothing against academia. I mean, I'm also a professor. But in France, it's kind of a little complicated. So now, go forward 35 years, 2015, I created a branch of FAIR in Paris. It's called FAIR Paris in 2015. So this is a branch of Meta's AI Research Lab. And this had an incredible effect on the local ecosystem in Paris. Some of you may not realize, but Paris right now is the hottest place in Europe for AI startups, or AI research for that matter, but startups in particular. And the reason, I think, is in large part because of the creation of FAIR Paris. So what happened with FAIR Paris is that it gave the idea to young, ambitious, aspiring scientists and engineers that they could have a career in research outside of academia in France, which was really not possible before. And so a lot of those young, talented students, instead of going to work in finance, decided to do a PhD in machine learning. And then, looked for a job there. If they didn't find a job at Meta, they did a startup, or they worked on other places. Now this FAIR Paris also attracted other labs. So Google DeepMind opened a lab in Paris. Now OpenAI has a group in Paris. And it just jump-started the ecosystem. So what do you need? You need high-quality universities with a high concentration of talents, so that it attracts industry to set up ambitious research labs locally, and you have one with VinAI, obviously. But you need more. And then it motivates young people to pursue careers in science and research, and it just lifts the entire ecosystem. Now, one advantage that Vietnam has compared to European countries and North America is young people, right? The average age in Vietnam is, 33 years? Mm-hmm. That's a huge advantage. So investment in research, investment in higher education, in STEM, in science, technology, engineering, and mathematics, and then giving opportunities for young, ambitious, aspiring researchers and scientists to stay in the country or to come back, like you did.
Thank you very much, Professor Jan Le Kun. I hope that answer satisfied you, the audience. And now I think that we have 3 more spots for the questions for our panelists today. So, yes, please.
Hello. Thank you. I'm really excited to be this forum. So I think my history. 10 years ago, I've done diploma work on AI. I was doing neural networks, and at the time, professors were telling me that I'm crazy. What I'm doing? Nobody really were understanding. And therefore, I have 2 questions. So this question is, all this boom with AI, all these investments which are driven by the companies, so what are the real, because today we don't see a real practical business outcome. So what do you see, what is in the future? What are the practical examples of application AI which can really bring GDP growth, and what is the future there? And the second question, today we are still, I think 5 years ago we were at learning phase where with AI was learning. We were trying to understand how to learn, how to teach AI. Now we are in perception phase. We can ask questions to AI. AI can answer to us. But still, we are not in action phase. We do not really allow AI to act. We don't have robots like in the cars. Still, cars are not driven by AI. So, is there any risk? How to manage it? And when do you think this action phase will become the reality? These 2 questions.
Thank you very much for your 2 questions. So, moderator, who do you want to address these questions for?
Well, on the second point, as far as the action phase, so it's not so clear that we have to rush to the action phase as far as giving control to machines if we're not quite sure what they're going to do. So I think as far as the immediate applications, clearly it seems to be to help people do their current jobs, is to improve their capability to do whatever they're trying to do. So AI is basically tries to replicate human capabilities, and so in all the different areas of human activity, it can help to individuals to do that better. And I presume that the business applications of AI will be in that general area.
So I think it's not fair to have 2 questions by you, but I will talk briefly anyway. The company that made most of the money is the chip company. Think about NVIDIA. How many people are actually buying GPU, right? The software layer on top of that, we start to see a lot of companies like Microsoft, Google, Meta, they're all rushing to really create that productivity software. Also, advertising is really probably one of the biggest category in terms of using AI. So the impact of AI, I don't think there's any doubt. Now, if you look at the healthcare, education, and they're all really going to change, in my opinion. So, but if you want to just measure on the financial return, NVIDIA is the best company that really harvested the imagination of AI.
Thank you very much, panelists. And now it's time for the very last questions for our panelists today. So I want to invite, yes, the man over there in black suit. Yes, please. On the front row, yes.
Sorry, I don't wear a black suit.
Sorry,
All right.
because yes, there are many men in black.
Okay, so the question is for anh Minh Đỗ. So first of all, thank you so much for your contribution to Vietnam. Even like before you joined the VinUni, many of my friends able to come to the US because of you. Okay, and I love the way you talk about AI in healthcare. So AI moved really fast LLM, many things. But one part in healthcare, the AI contribution is still very slow. Drug discovery. Okay, so right now, we are pitching to the US investor, saying that, hey, in the US, you have been doing drug discovery for many years. It's time maybe we should leverage AI to do drug discovery in developing country like Vietnam. So my question to you is, any recommendation of what it takes to build a world-class drug discovery AI-based company in Vietnam? Or let's say research, another VinAI in drug discovery. Thank you.
I'm not sure I'm qualified to answer that question. I know there's a lot of effort now using AI. Basically it's an automation of a very large search process, right? A search space using data. I don't think Vietnam have advantage there, right? Because we don't have a major pharmaceutical company. We don't have the kind of the discovery-based platform yet. On the other hand, I do think there are conditions like real-world clinical trial testings in which maybe AI can provide an angle to maybe more reliably collect the data in the field, and Vietnam, because of this large populations and also the healthcare conditions, it is capture some of the elements that really many other developing countries have. So the benefit of having people who are willing to try AI and these healthcare systems, maybe that's where we have an edge, right? But yeah, I think the audience has many more other experts, and I believe tomorrow we would have some more symposiums on exactly this topic.
Thank you. And perhaps I can add one more thing. Because of generative AI, you can really have AI helping you to get a lot of work done. The good example is like Cursor. It's an amazing tool to help people to program, to code. Essentially, you can have 100 junior developers working on your behalf. If you have a good idea, this is going to change the landscape of new startups. Not to mention, if you look at the big companies like Google, Microsoft, they're actually relying on, or they are behind in comparison to OpenAI and Anthropic. The two leaders in Silicon Valley are all small companies. They're not Microsoft, not Google. So AI is going to really leveling the playing field for all of us. We're all on the same level. If you need 100 people, hire Cursor or GitHub Copilot. You already have 100 junior developers. But the most important thing is you need to have a great idea yourself to know what is market technology fit. That is the key differentiation.
Thank you very much, Dr. Xuedong Huang, for your conclusion. Thank you very much. And now it's time to end our symposium today with the answers of our panelists. One more time, please kindly give a round of applause for our panelists. Top science of the world coming here in Hanoi, Vietnam. Thank you very much for your devotion, your entire life for science and to the humanity. And thank you very much, our audience, for your active participation today. And I know that there are still a lot of questions waiting to answer by panelists, but don't afraid. We still have break time. To all the audience, our panelists and prominent local scientists in the field to network and connect with each other. And I would love to invite all of you to join 3 different rooms for 3 assigned topics outside. And the session will last for 1 hour and close at 15:45. And don't forget to watch VinFuture Prize Award Ceremony 2024, premiered on VTV1 on 6 December. Thank you very much. Goodbye and see you tomorrow. One more time, thank you very much.
Thanks so much. Thank you.